Let's begin with the first example of trigonometric substitution. And if I haven't said this earlier, these are horrible, horrible, terrible things to do. They take something that looks as simple as the integral of square root of 1 minus x squared, and it gets a whole lot worse before it gets better. Well, if you look at this, you're probably thinking, man, if it only had a little x in there, then we could set u equal to 1 minus x squared, du would be negative 2x dx, the x dx would be du over negative 2. This would be easy to solve, but it's not. Next you think, hey, I see 1 minus x squared, that makes me think of 1 minus sine squared as being cosine squared. So let's set x equal to sine of theta. That means that dx is the differential. Derivative of sine is cosine, so dx is cosine theta d theta. And that means that this integral that we're trying to solve, square root of 1 minus x squared, becomes square root of 1 minus sine squared of theta, and then the dx becomes cosine theta d theta. It's very easy to forget about that. Lots of people are forgetting dx's all the time. In any case, 1 minus sine squared, as we said, is cosine squared, so you get the integral of the square root of cosine squared times cosine of theta d theta. The square root of cosine squared is just cosine, so you get cosine times cosine, cosine squared of theta d theta. Now, not too long ago, this in and of itself was a pain in the butt to solve, right? But now you've gotten some experience with it, you think, oh, half-angle formulas. Cosine squared is 1/2 1 plus cosine of 2 theta d theta. Just leave the 1/2 out front. The integral of 1 is theta, whose derivative is cosine of 2 theta. Well, you want to do sine of 2 theta, but the derivative of that is cosine of 2 theta times 2. So you use 1/2 sine of 2 theta. So the integral of 1 d theta, it's not dx, is just theta. And the integral of cosine of 2 theta is 1/2 sine of 2 theta. You could use u substitution, u equals 2 theta, du is 2 d theta, so d theta becomes du over 2, and that's how you could get your 1/2, but at this point you need to start doing some stuff in your heads. Well, now you look at this and you think, how do you get this back in terms of x? Well, where did we have the substitution? See, with u substitution it's really easy to just, because you know what u is in terms of x. Here you've got to solve for theta somehow. So x is sine of theta. We don't have a sine of theta, we have a sine of 2 theta. Well, first of all, if x is sine of theta, then theta is sine inverse of x. So this theta here is the arc sine of x. Second of all, sine of 2 theta, we don't have anything about double angles here, but then you think, wait a second, sine of a plus b is sine a cosine b plus sine b cosine a, as we did in Calc 1, and that means that the sine of 2 theta is sine of theta plus theta, which is sine of theta cosine theta plus sine of theta cosine theta, or 2 sine of theta cosine theta. So this theta can get turned into the arc sine of x, and we leave the 1/2 there, and sine of 2 theta is 2 sine theta cosine theta. So you replace the sine of 2 theta with 2 sine theta cosine theta, and then you say the 2 and the 1/2 cancel out, and well, let's see, we know the sine of theta is just x. Well, that's good. So sine of theta is x. Hey, wait a second. If sine of theta is x, we could draw a triangle. Oh wait, okay, no, we haven't done that yet. Right, then we replace the sine of theta with just x, then we draw the triangle, and we say, what does a triangle look like whose sine is theta? It's got an angle of theta, and the opposite over hypotenuse has to be x. How about x over 1? If that's x and that's 1, this squared plus this squared has to be 1. That makes this the square root of 1 minus x squared, and therefore the cosine of theta, which is the one thing with thetas we have left, is square root of 1 minus x squared. And that tells us that cosine is square root of 1 minus x squared. There is our answer. 1/2 the arc sine of x plus x square root of 1 minus x squared plus c. And just to verify this, let's copy this over. Just for the fun of it, I'm not having you do this on the homework, but it's not a bad practice. You know, you shouldn't have to look to me and say, did I get the right answer? You should know by taking the derivative. The derivative of 1/2 times something is just 1/2 times the derivative of it. The derivative of arc and the derivative of the c is 0, so that's going to go away. The derivative of the arc sine is 1 over square root of 1 minus x squared. The derivative of this requires the product rule. We have the derivative of the first, which is 1 times the second one left alone, plus the first one left alone times the derivative of this. And the derivative of that is what? That's 1 minus x squared to the 1/2 power, 1/2 1 minus x squared to the negative 1/2 power times the derivative of what's inside, which is negative 2x. And the x's, the 2 cancels with the 1/2. And what have we got over here? We've got a 1/2 out front. We've got 1 over square root of 1 minus x squared plus square root of 1 minus x squared minus x squared over the square root of 1 minus x squared. So this is 1/2 1 over square root of x, 1 minus x squared minus x squared over that is 1 minus x squared over the square root of 1 minus x squared plus square root of 1 minus x squared. Aha! And what is this? This is 1 minus x squared to the 1/2 power to the 1 power over 1/2 squared to the 1/2 power. That turns out to just be 1 minus x squared to the 1/2 power plus the square root of 1 minus x squared. This is 1/2 square root of 1 minus x squared plus square root of 1 minus x squared. That is 1/2 of 2 square root of 1 minus x squared, which is just the square root of 1 minus x squared, which all the way back was what we were trying to find the antiderivative of. So, we have the right answer. This is the most general function whose derivative is the square root of 1 minus x squared.